Hello friends, in this lecture we are going to solve this interesting problem to find the sum of digits of a given number. So first of all we will have to understand the problem statement. The problem statement states that you are supposed to find the sum of digits of a number. You must be aware that a number is composed of various digits. So we are supposed to find the sum of digits of the number that's given, and then we need to display the sum. So let's try to understand this by taking some example. Let's say the number n is 1682. This is a 4-digit number. So in this there are 4 digits, digit 1, digit 6, digit 8 and digit 2. So what we need to display is the sum of all these digits. That is, we need to display 1 plus 6 plus 8 plus 2, which is equivalent to 17. So 17 should be the output if the input is 1682. In the same way, you can have a different number as an input. Okay, so the next input here, let's consider it as 32. It's a 2-digit number. So sum of digits should be 3 plus 2, which is equivalent to 5. So if 32 is your input, 5 must be your output. So this is the problem that you are supposed to solve. In order to solve this problem, you may be thinking, how do I extract digits of a number like this? So in this number, this is a number, 3-digit number, 169. How do I extract digit 1, digit 6 and digit 9? I need to extract from this number digit 1, digit 6 and digit 9. After I extract, I have to add these 3 digits to get the answer, which is 16. Okay, so first thing is we need to extract digits of a number. Now this number, the number that we are talking, is a decimal number, right? And if you can recall, if you divide this number by 10, if you divide any number by 10, okay, what would be the remainder? By the remainder theorem, you must be aware that the remainder r would be greater than equals to 0 and less than 10, right? So the remainders in this case would be either 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the digits of my decimal number system. So if I divide my number by 10, I will be able to get the digits as a remainder of that division. Okay, so now let's try to execute this on this number 169. The idea is very simple. We'll divide by 10 and note down the remainders. So first of all, the number is 169. I'll divide the number 169 by 10. So 10 times 16 is 160 and the remainder is 9. So see, here we could extract the digit at units place. So this is my digit D. Okay, now let's try to write this statement for this. So how did I extract digit D? D is nothing but my 169 is the number n. Okay, mod, because to find the remainder I have to use this modulo operator, 10. If I do 169 mod 10, I get the digit D, which is 9. Okay, now I need to get the digit 6 as well. 9 is done. How do I get the digit 6? In that case, I'll have to divide 16 by 10 and not 169, because if I divide 169 by 10, I get the remainder as 9. Now in the next case, I need to divide 16 by 10. Okay, so how do I get this 16? 16 is very simple. The new value of n would be, previously n was 169, the new value of n would be 169 divided by 10. So if I divide 169 by 10, I'll get 16 as answer. So 16 is the new value of n. So here I divide n by 10 because now n is 16, n by 10. So 10 times 1 is 10 and the remainder is 6. See, I could be able to extract this digit 6. So this is my digit D. So now let me write the statement for this. How did I get my digit D? Digit D is nothing but n here. N is 16. 16 mod 10. If I divide 16 by 10, the remainder is 6. Okay, this is my digit. And what is the new value of n? So new value of n is 1. This is my new value of n. How do I get this number? I divide 16 by 10. The quotient is nothing but 1. So I'll continue this process, and now I divide 1 by 10. Okay, so 10 times 0 is 0 and the remainder is 1. Now see, I could extract the digit 1. Okay, so this is my digit D. So how did I get my digit D? It's very simple. Digit D is equals to 1 mod 10. If I divide 1 by 10, the remainder is 1. This is my digit. And my new value of n would be how much? N is 1 divided by 10 and the quotient is 0. Now at this point what I have done is I've extracted all my digits. Okay, so my first digit extracted was 9, the second digit that I extracted was 6, and my last digit was digit 1. Okay, now once I extract all these digits, I can actually add these digits to get my sum. Okay, so how do I add is, initially we'll assume that the sum initially to be 0. Okay, my sum is initially 0, so the new sum here is nothing but the old sum, that is 0, old sum 0 plus the digit 9. Okay, 0 plus 9 is 9. Okay, in this scenario the sum at this point would be the previous sum, which was 9, the previous sum, that is 9, plus the digit 6, so 9 plus 6 is 15, and in this case the sum would be the previous sum, which was 15, plus the digit 1, which is equivalent to 16, and if you can see, 16 is my answer, right? 1 plus 6 plus 9 is 16. This is what I need to display. Now if you can see here, do you see a pattern? Do you see that I have repeated the same thing again and again? Just look at this. Here I am dividing 169 by 10 and noting down the remainder and the quotient. Here I am dividing 16 by 10, noting down the remainder and the quotient. In this case I am dividing 1 by 10, noting down the remainder and the quotient. And then I stop here, right? Now I do not know beforehand how many times I need to repeat. I am repeating here 3 times, but I did not know this before I start doing the repetition, right? So this repetition is not controlled by any counter value, but this is controlled by the value which is 0. This is nothing but whenever n becomes 0, I stop. Okay, see, initially n was 169, so I do the division. Then the new value of n was 16, so now again I do the division. The new value of n was 1, then again I do the division. Now the value of n is 0, so I have to stop my loop. Okay, so this kind of a loop, which is not controlled by the counter value but by some other value, is called as a sentinel-controlled loop. In this case my sentinel value is n becoming 0. Okay, so while loop is generally used for writing the sentinel-controlled loop. Okay, so let's try to write this here. So first of all, let's scan the number. Okay, the number here is n, the number is n, scanned from the user. Okay, I'm assuming that n is already declared here. Okay, now I have to run a loop. Let's write a while loop. Okay, now let's write down the condition. What would be the condition? Condition is, if n is not equals to 0, I'll repeat, right? N is not equals to 0 is my condition. Whenever n becomes 0, I'll have to stop, right? So whenever n becomes 0, I'll stop. Okay, so I'll stop when n becomes 0. Okay, if n is not 0, I'll have to repeat something. What am I repeating? If you see, I'm repeating these 3 statements, right? First finding d, getting the new value of n, and doing the sum. Okay, so this is what I'm repeating. These 3 statements are being repeated. Okay, so I'll just write this statement here. So I'll find the digit d. Digit d is what? This is n, right? This is n mod 10. Okay, n mod 10 would give me the digit. Okay, so initially let me create a variable sum. Okay, here let sum be the variable, initialized to 0. Okay, initially sum is 0. Now I find the digit is done. Then the new value of n would be the old value of n divided by 10. So I'm just doing this operation. This is n divided by 10, right? So this is n, this is 10. N divided by 10. This is nothing but n divided by 10. This is n mod 10. Okay, so n divided by 10, I'll get the new value of n. This is like updation. Okay, because for the next iteration the value of n would decrease, right? Initially n is 169, for the next time n is 16, for the next time n is 1. Okay, so updation of n is done here, and then I'll have to add it to sum, right? The old sum, this is the old sum plus the digit d. Okay, plus the digit d. So if this loop continues, okay, this will continue till when? Till n becomes 0. Whenever n becomes 0, it will come out of the loop, and then after the loop, so here you can display the sum. So I can just write display sum here. Okay. So you can write a printf statement to display the sum that should come outside of the loop. So I hope the idea is clear to you. Now we are going to write a computer program to demonstrate the same. So in order to find the sum of digits of a number, first of all, I need to think how many variables I'll be needing. So first of all, I'll be needing a number, okay, for which I would be finding the sum of digits, okay. Then I'll be needing a variable to store my digit. Then I'll also be needing a variable to store my sum, which I initialize to 0, okay. So these are the variables that I need. Now let's take the input. So the number is scanned here. So the number is n, this is the input, okay. Now let's do with the processing. Now here I need to write my loop, okay. So I'll write here, this is my sentinel-controlled loop, okay. So here I'll loop n not equals to 0, this is the condition, we have already discussed this, okay. And inside the loop what I do is, first of all I'll find my digit. How do I find my digit? I'll divide the number by 10 and store the remainder, n mod 10, so digit will be stored. So the digit will be now stored in the variable d, and now I update the variable n. So the new value of n would be previous value of n divided by 10, the quotient of n divided by 10, and then I'll have to add the new digit to the sum variable. So it will be sum equals to sum plus d. Okay, so this loop will continue for all the digits of a number. Once it is done, it will come at line number 21, and then here I'll have to display the sum of digits. Okay, so I'll write printf sum of digits equals to %d, and then here I'll write sum. Okay, so this is my output. Now let's try to compile this code and then see how it works. Okay, so let's say the number is 169. And you see sum of digits is 16, which works fine. You can try with any other number, 1, 2, 3, 4, 5, 6. Okay, so the sum is 21. You can try with a simple number 23. The sum is 5. You can try with a single digit number 9. Sum is 9. There's just one number. Okay, so this is how you actually write a program to find the sum of digits of a number. Okay, so here we have learned how we can design and implement the sentinel-controlled loop. I hope you have understood the working of sentinel-controlled loop and the program to find the sum of digits of a number. That's all in this lecture. Stay tuned for exciting lectures in the future. Thank you.